Hello, everyone, and welcome to this show and tell, uh, hosted by me. And I have YouTube on somewhere. Yes, found it. Can hear myself talking, but very delayed. So, welcome to Show and Tell. This is the third time of the week that we get together to show off what people are doing, both Adafruit folks and people in the community as well. And so we take a couple minutes, unmute if you are muted, and tell us about what it is you're working on, what you're up to. And we'll start with some Adafruit folks, and then we'll head over to everybody else who pops in. So first up, let's go see what's going on with JP.
Oh, hello.
Hello.
Nice to see you.
Nice to see you as well.
So I just wanted to come on with a kind of fun little weird show and tell that I have, which is these little railroad crossing gizmos that I picked up at an estate sale a few years ago, and I haven't really done anything with them. But this one rings a bell when you get train crossing, and this one has the little crossing gate here. This one's got a little solenoid in it to pull the gate up and down. And to just sort of explore it a little bit, I hooked it up to this little, it's called a field kit. It's sort of a audio recording synthesizer processing kind of gizmo that happens to have a little low frequency oscillator on it that you can use to drive a DC driver. So if I turn this on, it's gonna start driving this little gate up and down using its low frequency oscillator. And I don't know what this thing was meant to run at. I don't know a heck of a lot about railroad stuff, but it seems to be working at 12 volt, which is what that driver circuit can drive. And I don't know what current it's capable of. And I should probably test all this before I just burn things out. But we'll see. I may be able to even tune the speed of it using the low frequency oscillator. Here you can see it doesn't want to get all the way to the bottom of its range anymore, but it's going faster.
Yeah.
So this thing is also, this little Coma field kit is meant to use piezo pickups so that you can pick up audio of things that you're doing. So I may, when I hook it up to this thing, you'll see we get some buzzing sounds and things. So I may try to use that and then process those sounds into other synthesizer parts. Let's see if this will.
Oh.
So I can send it like a square wave or a pulse instead of the triangle wave that I was. So there's a lot of options of ways to try to drive the thing. Yeah, there, it'll probably go for little fast pulses.
Yeah.
And then I also happened to, just to make it easy to see what was going on, I plugged a big fat LED with a resistor into the same little circuit there using screw terminal barrel connectors. So that's how I'm driving that. And it's just fun for experimentation. So we'll see what comes of that, but I thought it'd be a fun thing to show off.
Yeah, absolutely. Well, thank you very much.
You're welcome. Bye.
Bye. All right, next up, let's talk to Jeff. Jeff, what are you showing off today?
Hi there. So I've got two little projects that I want to show. First one, a project that I had wanted to do for many years. There's this old style of display called an edge-lit display, and it has a series of panes of glass in it, and they're each engraved with dots forming a number. You just put 10 of them front to back, an LED under each, and drive them with software. In this case, it's a Feather M0 because it doesn't take very much processing power. And the program that's running on it is just showing all of the prime numbers. So it's gotten to 2,399, which I guess is prime. If we start it over with the reset button, it'll just count 2, 3, 5. I'm faster than it. 7, 9, or 11. 11. 9 is not a prime. See. So anyway, this was a this is a kind of display that was used back like in vacuum tube and relay computer days, and it fell out of favor. But it's fun. Like a Nixie tube is fun, and I just wanted for many years to make one, but I didn't have access to a laser printer, or not a laser printer, a laser engraver, which is what I use to engrave the glass. So when I got access to one, I'm like, I can finally do this project, and I've made 1 digit, and the idea of completing like a 4 or 6 digit clock is just still a little too daunting, because you spend a lot of time on the laser printer or on the laser engraver, and the results are a little bit mixed. But I have here. Oh, maybe I don't have here. Well, anyway, it uses slides like you use for a microscope.
Oh.
And so they're a defined size and a very well-defined thickness. And then it's a little 3D printed enclosure that goes around the whole thing, and a custom circuit board, which I can't really show you, with 10 LEDs and 10 resistors, that is in the Featherwing format. So that's item number 1.
Very cool.
And item number 2, I was inspired by a guide, which I think was by Carter. He did a dice rolling app for Clue, and so I had to do my own version of that. So this is Clue running my app, and of course she can't make it out.
A little bit.
But there's a role-playing system called Fate, which is tabletop role-playing, but it really kind of encourages you to tell stories more than worry about just how many hit points an orc has and that kind of thing. And their way of rolling is there are 4 special dice with a plus, a minus, or a blank on it. And you add those up and you add them to your skill, and then that's your result. So here, if you shake it, whoops, it'll give you a result. If you shake it, it'll give you a result. And then also you can use the proximity sensor. So
Very
just
cool.
a little bit of code, a few graphics, which you can't see because they're all blown out, but these are 4 dice images up here. And yeah, just a fun little thing that I will use this weekend when we virtually get together, some friends and I, and do a little role playing.
Excellent.
So anyway, that's what I'm up to. There's some other things that are going on with the RGB matrix, but I don't want to steal anybody's thunder about that, right?
Right.
See you later, Katney. That's what I've got.
All right. Excellent. Thank you very much, Jeff. Next up, let's see what's going on with Melissa. Hey,
Hello.
Melissa.
Hi. So what I am working on here, it's actually a project I'm just starting to spin up here, but I want to take this quadcopter drone, and I want to replace the board in it with a feather Bluefruit Sense and a motor feather. And it's able to control 4 DC motors, which is perfect for this. And I want to communicate to it with Bluetooth. So I'm just kind of like starting to get the code together here and doing a little research at this point, but it's coming along.
Anything you plan to do with the feather sense itself with the sensors it has on it?
Yeah, actually, the magnetometer especially, that way I can see whether it's level or not, and it's going to be using the sensors, which is one of the reasons I chose this as the board. I'll probably have to remove a bunch of these connectors just to reduce the weight here, but I'm thinking about maybe like piggybacking one on top of the other just to lighten the load a little on there.
Yeah, that makes sense. Very cool.
Yeah.
Well, good luck with that, and keep us posted.
Thanks.
All right. Excellent. Next up, let's see what's going on with Roy.
So I heard about and started messing around with Jeff's RGB matrix support in CircuitPython. And so we've got an RGB 64 by 32 matrix here with the Featherwing and a Feather M4 on the back, and a 5-volt power supply to keep it happy. Running CircuitPython 5.3.0 or RC0, and I haven't really had a lot of time to mess around with anything but the examples on the Adafruit RGB LED matrices guide. But it's a lot of fun to play with, and I'm going to start that up now. And the only thing I did that was different from the examples, I wanted each of the lines to run at a different speed. And so thanks to everybody that's been making it easier to make CircuitPython do cool stuff like this. It's the kind of stuff I love doing.
Excellent. All right. Well, thank you very much. Now let's check in with Chris. Hi, Chris.
Hi, welcome to my basement.
Thank you very much.
So I've got a project that is essentially 4 projects rolled into one, and if we can switch to my other camera, or do I need to do that myself?
I think you need to do that. I don't see it.
I will switch to it. There we go. A lot of nothing. So it's an IoT project, and what I've got here is an Adafruit Itsy Bitsy. Now, I tried to do this with the Trinket, but I ran into a couple issues doing that, which you'll see in just a sec. So I've got 2 of these sensors here, and each of these sensors is communicating over I2C to a little screen and the temperature sensor. And eventually I'm going to have about 5 or 6 of these. I'll tell you why in just a sec. Then I've got a Raspberry Pi, which is also communicating over I2C to each one of those Itsy Bitsy devices. And that, because I needed to go from the Raspberry Pi to the Itsy Bitsies, as well as the Itsy Bitsies controlling other things by I2C, I needed to create another I2C port. So each one of those Itsy Bitsies has to have 2 I2C ports. And that took a bit of figuring out, but a couple of Adafruit guides later, and they're working. And once it collects that data, there will be a screen that this is kind of fake right now, but it's going to display which of the sensors are reporting data, which aren't, and then the data gets sent to Adafruit IO, which we're looking at right there. And then the last piece of this project, because I like doing things complicated. This is another, this is just on my iPad, but this is connecting to an app in the cloud that is contacting the Adafruit cloud to pull the data and display each one of the sensors in a little card. And I've got it somewhat working at the moment. It is pulling data and displaying it, just not grouped into the right sensors yet. So
very cool.
Yeah, it's yeah, like I said, it's kind of like 4 projects in one there.
And what do you plan on sensing?
Oh,
like where do you plan on putting them?
Yeah, so I am in the basement, as you can see, and that's both the temperature and the humidity in here are kind of crazy, go up and down a lot with the year. And I do a lot of 3D printing, and I have a lot of filament that I don't want to get very humid. And so the goal is to have one of the sensors in each one of my filament boxes, one inside the printer enclosure, and one for the room itself where the 3D printer is.
Gotcha. Makes a lot of sense. And it's an excellent way to keep track of everything. Well, thank you very much for showing up, and keep us posted on how it goes.
All right.
Thanks.
Thank you.
All right. And with that, we have gotten to everyone. So thank you very much for joining us today. I am going to have Roy's screen play us out. Thank you to everybody who showed off their projects. Greatly appreciate it. And I will actually be hosting John Park's show and tell next week as well. So feel free to come on by. There's lots of show and tells now during the week. So if you can't make it to this one, don't worry. You have plenty of time and different ways to show off your stuff. But if you can, stop by again next week, Thursday at 5:30 Eastern. We will be here and ready to show off whatever it is you're up to. So thanks again, everyone.